In this video, we'll talk about how to adjust the stability for your rocket. Maybe the most important thing you do with your rocket is to make sure that it's stable, so at liftoff it goes where it's supposed to go. And to do that, you pay attention to a couple of things. This blue dot right here is the center of mass. And just as you might expect, right now, if I wanted to balance this rocket on my finger laying sideways, I'd stick my finger right here, and this rocket would balance. That's center of mass. And there's things you can do to make that move around. I'll show you that. The red dot is center of pressure. What that's saying is that as air comes in from the left, as this rocket's going up, the air hits the nose of the cone, as you know, and it tumbles down the side of the rocket, and it puts pressure on the rocket. And right now it's saying the average location for pressure is down here. Now I'm going to show you something. Watch this. If we get rid of the fins, watch where the center of pressure goes. I'm going to get rid of the fins. Look what the center of pressure is now, way up here. Now think about that. The wind's coming in, it's hitting the nose of the rocket. All the things grabbing, everything on this rocket that's grabbing air is really the nose of the rocket as this rocket's going up. So the center of pressure is focused on the nose of the rocket. When you add fins to that, so let's go to the fin can, let's put our fins back in there. There they are. Notice that the center of pressure came way back down here, and that's because the fins are grabbing a lot of air. It moves the center of pressure down. That's what your fins do for you. That's why you have fins on a rocket, is to bring that center of pressure down. You want the center of pressure fairly low on the rocket. Right now it's a little bit higher than we probably like it to be. The feature you're looking for is actually the distance between these two dots, center of pressure and center of mass. You want a certain stability rating for how far apart those are. When these two are as far apart as the diameter of the rocket, that gives you a stability rating of 1. If these two were twice the distance as the diameter of your rocket, that would be a stability number of 2. You want your stability numbers between 2 and 3, so these need to be further apart. The second thing is you want your center of mass to be to the left of your center of pressure, as it is here. You actually want your center of mass as high up as you can get it realistically, because it actually helps it balance. You might try it sometime. If you hold a stick on your finger vertically up, if you put mass at the tip of the stick, it gets easier and easier and easier to balance. As you move the mass down towards your finger, it actually gets harder to balance. It's something you might try. Rockets behave the same way. There's a tremendous amount of thrust coming out of the bottom of the rocket, and if the mass is further forward on the nose, it actually gives you a more stable rocket. Now OpenRocket keeps track of that stability number for you right here. Right now, this rocket has a stability of 1.8. That's not too bad. We'd like to see it above 2. 1.8 would fly. I've launched a rocket with a stability number of 1.5. But notice I've taken the motor out of this. We're going to put the motor back in. Now watch, so the motor has mass. It should affect where the center of mass goes when I do this. So let's go in here, let's do motor configuration. We're going to go back and put that SD's E96 back in there, just like we did before. There it is. It's right there. We're going to put a delay of 6 on it, like we did before. And notice where the center of mass went. Center mass is now to the right of the center of pressure. In fact, look at that. The stability number is now a negative number. As you add mass to the rocket, it's going to affect where this goes. You need the center of pressure to be to the right of the center of mass. And you want your center of mass as high up as you can possibly get it. You control the center of mass by what mass you add to your rocket. As a matter of fact, that's why here there's an object right here just called mass, where you can just add mass to help move your center of mass around. Center of pressure, again, is how much the rocket's dragging through the air. Well, fins have a lot to do with that. If we look at the fin set, watch what we can do to the center of pressure by playing with the fins. Look at the fin set. Let's look at the edit of the fin set. If I just make the fins, I don't know, taller, let's see what happens. This is height. If I make them taller, what happens to the center of pressure? Ooh, look at that. Look at that. Ooh, wow. Nice, nice. Getting a pretty good center stability number by playing with the fins. Okay. Now, right now I'm better. There's other things. I haven't added bulkheads and center rings and things like that. So there's more mass to be added, but that's how you adjust the stability number. Again, you need your stability to be a positive number, which means your center of pressure is to the right of the center mass. You actually want your center mass as far forward as you can get it. And you'd like to have a stability number somewhere between 2 and 3. Playing with the fins helps you with center of pressure. However, I got to warn you, as you play with your fins, your rocket could get slower and slower and slower. Really big fins will make a slow rocket. It could be so slow that it doesn't launch with enough velocity, and now you have a dangerous rocket coming off the rod. So these are things that we'll talk about a little more when we go to our simulation of our rockets and a little bit about launching them. But for now, that's how you affect the stability number, a key feature to a rocket. Again, between 2 and 3 is where you'd like to see that number. Center of pressure to the right of the center of mass. More about how those work together as we do some simulations. And that'll be in our upcoming video.